There's a section just on sample rates. This is where the nuts and bolts of audio conversion really happen. What is A to D and D to A? So an incoming audio signal is a physical thing that is like why the sky's blue and what happens to the refrigerator light when you shut the door. Grand mysteries of the universe. It's an electromagnetic thing. It is a wave with an infinite resolution, technically. This comes into really technical mathematics, but essentially the curve of an audio signal is really hard to quantify. And that means like, well, how would we graph that? Like how do you technically graph something that has an infinite resolution? And not to get too heavy into physics, but long story short, we have to find some way of making something that is really hard to define definable so we can store it in a computer. So what happens is you have a curve, and as time goes by, your interface is marking out points, essentially graphing the signal that's coming into your computer. It's taking something that looks like this and turning it more into a square situation so you have an approximate for where that signal was as it continues through time. This would be a lot easier if I had like a board to write on. Essentially, it's a report of where an audio signal is. At 0.05 seconds, the audio signal is here. At 0.051, it was here. At 0.052, it was here. At 0.053, it was here, and so on. So essentially, when they say 44.1 or 48 kilohertz, that's literally saying that it's being sampled 44,100 times per second, or in 48K, 48,000 times per second. That means as 1 second goes by, audio is being graphed out in these little tiny dots that your computer is going to record. It's taking an analog signal, which is technically infinite, and turning it into a graph. That graph data is easily stored as an audio file. And then when that audio is played back, the D to A, which is digital to analog conversion process, is going to happen, where that plotting is going to be sent out from your computer to your interface. Your interface will convert that to an analog signal, which is going to come out of your speakers or your headphones, depending on whichever ones you're listening to. Again, the better your interface, the better that conversion quality is going to be, and the better your audio is going to sound, because this is a very precise operation. So that's one of the things to consider when you're getting your interface. How well is the conversion process happening? So the more samples we take through time, the more data we are creating. So the more accurate it will sound, but also the more space it's going to take up on your hard drive, and also the more CPU power it's going to take up as well. So you want to make sure you're choosing the right sample rate for your projects. Most CDs are at 44.1 and 16-bit depth. Again, that's 44,100 samples per second and 16 steps of amplitude. So a graph must have an X and a Y. It is 44.1 this way and then 16 this way. It's a nice graph. But there are higher resolutions. Also, again, at the cost of CPU cost, it will be harder for a computer to process that much more data. And also you'll need more space to save more data. So if you've got an awesome computer, by all means record at the highest resolution you can, capture the most detailed recording you can, and if you've got the space to save it all, do so. Most people don't, and that's why you would record at slower or lower sample rates. A common application for higher sample rates are like sound design people who are going to record something and then slow it down. So they would want to record it at something super fast, like 96K, so that when they slow it down, all that resolution is still there. It's kind of like if you take a photo of a big photo, but you want to zoom in on something far away, you would need to take a really high resolution photo so that when you zoom in, the object is still in focus. Sound design people will record at super high resolutions so that when they zoom in and slow things down and manipulate the audio, it still looks or sounds really good. Again, 44.1 and 16-bit depth was and is still a CD standard, and that's what most like high quality CDs are going to be. So recording at that is a great place to start, but if you have the power, experiment with some higher rates, see if you hear a difference, and move forward from there. If you're getting audio dropouts and a low performance from your computer, you might want to back the sample rate down a little bit so that your CPU can manage all the data. But again, to recap, sample rate is the rate at which you are graphing the analog signal that's coming in to a graph, the resolution of that graph, and the amount of data you're producing. Higher sample rates are more accurate, they create more data, and they're more intense on your CPU. Lower rates create less data, are less accurate, but are easy for your CPU to process. Find the one that's right for you.